Question 31. Electronics and Communication Engineering, GATE 2016 Set 2. In the circuit shown in the figure, the magnitude of the current in amperes through R2 is dash. For a detailed lecture on this concept, please refer the NPTEL video, Lecture 2, Voltage and Current Sources, a course on network analysis by Professor Tapas Kumar Bhattacharya, Department of Electrical Engineering, IIT Kharagpur. Let's have a look at the basic concept of Kirchhoff's laws before solving this problem. Consider a loop with two elements R1 and R2 which is supplied by a source Vs. According to Kirchhoff's voltage law, in a closed loop, the algebraic sum of the voltages of all the elements is 0. According to Kirchhoff's laws, Vs minus the voltage across R1 minus the voltage across R2 is 0. Next, let's have a look at the Kirchhoff's current law. Consider three branches where I1 is entering through one branch, I2 exits through another branch and I3 exits through another branch. According to the Kirchhoff's current law, the algebraic sum of the currents entering and leaving a node is 0. So in this case, I1 minus I2 minus I3 is equal to 0. Let's make use of these two concepts and solve this problem. In the question, the current that is flowing through this resistor R2 is asked. Let's have it as IA. We have to find out the value of IA. We have a dependent source of 0.4 Vx where Vx is the voltage across the resistor R3. To find out this current, we have to first find out the value of Vx. Let's apply the Kirchhoff's current law at this node. The current that is flowing through the first loop. Let us call it I1. By KCL, I1 plus 0.04 Vx is equal to Ia, where Vx is equal to 5 ohm into Ia. Let's substitute that over here. We will be getting I1 plus 0.2 Ia is equal to Ia. Therefore, I1 is equal to 0.8 of Ia. Let's have this aside and now let's find out the value of I1. By Kirchhoff's voltage law, we can say that 60 minus 5I1 minus 3Ia minus of Vx, or we can write Vx as 5Ia. So this is equal to 0. So this implies that 60 minus 5I1 minus 8Ia is equal to 0. We know that I1 is 0.8 Ia. Therefore, this implies that 60 minus 5 into 0.8 Ia minus 8 Ia is equal to 0. This implies that 60 is equal to 12 Ia and therefore the value of Ia is equal to 5 ampere. So the magnitude of the current through R2 is 5 ampere. Thank you.